Dear students, under the lecture series on complex analysis, we are solving problems under Cauchy integral formula. Now, here we have a problem under the topic higher derivatives using Cauchy integral formula. This is known, we are going to apply the higher derivatives method because in the denominator, we see that the power of one of the function, that is z plus 1, is 2. In that case, we have to use the higher derivative, that is, already we have seen if you have the power to be 2, then the formula turns out to be 2 pi I f dash of z naught by 1 factorial. If the power is 3, 2 pi I multiplied with f double dash of z naught by 2 factorial. In general, if the power is n plus 1, then the formula turns out to be 2 pi I f power n z naught by n factorial, which means nth derivative of this function. So now, here we have the power as 2. So first of all, we should rewrite this given integral in a form where we can apply the Cauchy integral formula. For that, since we in the denominator we have product of functions, we have to rule it out by using partial fraction. So let us rewrite this integral. For that, first we shall use the method of partial fraction in order to separate the denominators. So when we apply the method of partial fraction, we have to take and write 1 by z plus 2 multiplied with z plus 1 the whole square. Now this has to be splitted up by using partial fraction, where we will get it as a by z plus 1. Now the power of z plus 2 and plus b by, now if the power of z plus 1 is 2. So it has to be splitted as two terms, that is b by z plus 1 plus c by z plus 1 the whole square. This is by the method of partial fraction. Now from this we will get 1 to be equal to a multiplied with. So when you take the LCM, we see that a will be multiplied with z plus 1 the whole square plus b multiplied with, we need one z plus 1 and a z plus 2 plus c multiplied with z plus 2. This alone. So now, in order to find the value of a, b and c, we have to give values for z. So first we shall put z to be equal to minus 2 so that we can eliminate b and c and find the value of a. So if you put z as minus 2, 1 will be equal to a multiplied with, what is minus 2 plus 1? It is minus 1 square. And when you put minus 2 here, the term becomes 0. Here also the term becomes 0. Therefore from this we get, now minus 1 square will become plus 1. And therefore the value of a will become 1. Now to find the other, that is, we shall put z is equal to minus 1. So when you put z as minus 1, this term will become 0. And so 1 will be equal to minus 1 plus 1, it becomes 0. Here also minus 1 plus 1, it becomes 0. And here we will be having c multiplied with minus 1 plus 2, which is 1. And therefore we have obtained the value of c to be equal to 1. Now in order to find the value of b, we shall put z is equal to 0. So what do you get? 1 is equal to, if you put z as 0, you will have 1 square multiplied with a, so a. And here, if you put z as 0, here you will have 1, here you will have 2. So 1 multiplied with 2 is 2, so plus 2b. And then if you put this as 0, you get 2c. So plus 2c. So we obtain an equation. Already we have obtained the value of a and c. So we can substitute that in this. So from this, 1 is equal to a is 1 plus 2b we will write as it is plus 2c. c is 1, so we get 2. So 2 plus 1 is 3. So 1 is equal to 3 plus 2b. So from this, 2b is equal to 1 minus 3. So 2b is equal to minus 2. And we find the value of b to be equal to minus 1. So we have obtained the value of b also. Now substituting this over here, we get 1 by z plus 2 multiplied with z plus 1 the whole square to be equal to, a is what? A is 1. So 1 by z plus 2. B is minus 1. So we get minus 1 by z plus 1. and c is 1, and so we get plus 1 by z plus 1 the whole square. So now this has been splitted up into three different terms, and so this integral can be written as the sum of three different integrals. So let us rewrite this integral which has to be evaluated. And so we get integral over c f of z, which is e power z, divided by z plus 2 multiplied with z plus 1 the whole square dz. Now this integral can be written as equal to, this is the first integral, so integral over c e power z divided by z plus 2 dz. Then this integral minus integral over c e power z by z plus 1 dz. And then the third integral, so plus integral over c e power z by z plus 1 the whole square dz. Now we shall evaluate each of the integrals, and before that we have to check whether f of z is analytic. Now what is f of z over here? So the function f of z is equal to e power z. So we know that exponential functions are analytic everywhere. So therefore f of z is analytic inside and on C. So therefore f of z is analytic. Now we have to check about the points. So z naught. So in the first case, what is z naught? So we have z plus 2 to be equal to, that is z plus 2 is z minus z naught. So while comparing on both the sides, z naught will be equal to minus 2. And what is the given circle? The given circle is modulus of z is equal to 3, which means the circle is has the center as the origin 0 comma 0 and the radius is 3. So using this, we have to check whether the given z naught lies inside or outside C. So outside of C. So modulus of z is 3. So therefore, if you check here, if you take the modulus of z naught, it will be equal to modulus of minus 2. What is modulus of minus 2? It is 2 only. And 2 is lesser than 3. So therefore, since 2 is lesser than 3, we can say that z naught equal to minus 2 lies inside C. Now what about the second integral? We have z plus 1. So z plus 1 is equal to z minus z naught. And on comparing both the sides, we get z naught to be equal to minus 1 now. What about modulus of z naught? It is equal to modulus of minus 1, which is equal to 1. And we see that 1 is lesser than 3, of course. So which means z naught equal to minus 1 lies inside the circle C. And the last left out is again z plus 1 only. And we notice that when it is z plus 1, z naught equal to minus 1, and obviously it lies inside C. So for all the three integrals, z naught lies inside the circle C, and also f of z equal to e power z is analytic, and hence we can apply the Cauchy integral formula to all the three integrals. So we shall apply the Cauchy integral formula and we shall write this. So now when we apply the Cauchy integral formula, we see that in this first integral, it is that is f of z is analytic and z naught also lies inside the circle, and so therefore integral over c e power z by z plus 2 dz can be written as 2 pi I f of z by using this formula. So it can be written as 2 pi I f of z naught. So now here it will be equal to, I will write here. So this first integral will be obtained as 2 pi I f of z naught here is minus 2. So that is what we checked. And then minus, what about this integral? It will be 2 pi I and f of z naught here is minus 1. And then the final integral this, the power in the denominator is z minus z naught square. So whenever you have square, what is the formula? Here we have integral over c f of z by z minus z naught square dz. We have 2 pi I f dash of z naught by 1 factorial. 1 factorial is 1 only. We know that 1 factorial is equal to 1. So it will be 2 pi I f dash of z naught. And so that is, so here we have plus 2 pi I f dash of z naught is what? Minus 1. So now we shall evaluate each of this. We know that f of z is e power z. So therefore this will be equal to 2 pi I. Now f of z is minus 2. So f of minus 2 will be e power minus 2. So this is e power minus 2 minus 2 pi I f of minus 1. So f of minus 1 will be what? At the place of z, if you put minus 1, it will be e power minus 1. So e power minus 1 plus 2 pi I. Now f dash of minus 1 we want. F of z is e power z. So from this we have to find f dash of z, and that will be also equal to e power z only, because the differentiation of e power z is e power z. So now when you apply f dash of minus 1, it will be e power minus 1. So this is e power minus 1. Now we see that 2 pi I is common in all the three terms. So we can take it out. So what we get is equal to 2 pi I we will have in common, and within the bracket we will have e power minus 2 minus e power minus 1 plus e power minus 1. So minus e power minus 1 and e plus e power minus 1 will get cancelled. And so then the answer will be 2 pi I e power minus 2. So this is the value of the required integral. So hence we have evaluated the required integral. That is, we have evaluated integral over c e power z by z plus 2 z plus 1 the whole square dz to be equal to 2 pi I. So this is how we have to use the higher derivative Cauchy integral formula in order to evaluate integrals of this type. So I hope you would have understood this problem. Thank you.